All right, so welcome to today's class. We are going to talk about um, accuracy and precision. Okay, so we are going to define what accuracy is, what precision is, and how we can tell if certain measurements are accurate and if certain measurements are are precise. Okay, so we are going to start from the definition of accuracy. So on the next page here, I've written down the definition. Okay, I was saying accuracy is how close your measurement is to the true value. Okay, so how close your measurement is to the true value, that's what we call as accuracy. So if your measurement is accurate, okay, then it's going to be very close to the true value. And then if it's not accurate, then it's going to be far away from the what? From the measurement, or it's not going to be close to the measurement. Okay, so let's say example, my true value is 34.5. Okay, this is my true value. And then I get, let's attach units to this. So let's say my true value is the weight of something, and that weight is maybe 34, okay, 0.5 grams. And then I get this same thing, I put it on the measuring instrument. And then the weight that I get, okay, maybe it's 34.49 grams. Okay, so I'm going to look at this measured value and then I'm going to compare it to the true value. So we see that these two values are actually close, okay, because this is 34.49 and this is 34.5. So since these two values are close, the measured value is close to the true value. We're going to say that this measurement here is what? Accurate. Okay, but let's say my measured value, okay, after I put this on the measuring instrument, I found maybe my measurement is giving me 30.2 grams. Okay, so now I'm going to compare my measured value, which is 30.25, to the true value, which is 34.5. So are these two close? Okay, they are not close because this is 34 point something, this is 30 point something. So there's a gap there. So we're going to say that this measurement here is not what? Accurate. Okay, so that's how we can determine if a certain measurement is accurate or it's not when we are just being given one measurement, like the way I was giving it here. Okay, so what if now you have more than one measurement? How can you tell that, okay, these measurements are accurate or these measurements are not accurate? So for example, again, the true value, we're just going to say maybe the true value is 25 grams. Okay, and then now my recorded measurements, let's say I do this experiment like 3 times. So I found maybe 34.5, I mean 24.5, and then I find 24.49, and then the other one I find 24.51. Okay, so how can we tell if a number of measurements that we've done are actually accurate? Okay, so if you've been given more than one measurement, you need to find the average. Okay, so you find the average or the mean of the measurements that you've been given, and then you compare the mean to the true value. If the mean is close to the true value, then you're going to say those measurements are accurate. Okay, if the mean is not close to the true value, we're going to say that those measurements are not what? Accurate. So let's try to find the mean here. So to find the mean, I'm just going to add all these and then divide by 3 because there are 3. So I say 24.5 plus 24.49 plus 24.51. And then I divide by 3. So when I do that, I get 24.5 grams. So it is now this average value that you're going to compare with the what? With the true value. Okay, so 25 and 24.5, they are close. Okay, so we're going to say these measurements that we had there are actually what? Accurate. Okay, so in another case, you may find that they are not accurate. Okay, so for example, if let me erase this. If, for example, my measurements after I do the experiment maybe 3 times, okay, I get maybe 30.1 grams. Okay, I also get 29 grams. Okay, and then I also get maybe 28. Okay, 28.5 grams. So let's say these are my three measurements from my three experiment. So I'm just going to add them. So 30.1 plus 29 plus 28.5. Then I divide by 3. Okay, I'm going to find 29.5 grams. So now I ask myself, is this mean, okay, for the measurements that have been given, close to the true value? We've seen that this is 25, this is 28, so they are not close. So we're going to say this set of measurements here, or this set of results, are not what? Are not accurate. Okay, so what does it mean when we say uh, the measurements have a higher accuracy, okay, or they have a low accuracy? So if they have a high accuracy, then the values are actually near the what? The correct value or the true value. If they have a low accuracy, then we are going to say the values are far from the what? From the correct value or the true value. So that's the definition of accuracy, and I've illustrated, okay, what it means in terms of the numbers. So now this is just a picture that is depicting accuracy. Okay, so let's say you are playing that and you are aiming on this yellow spot here. Okay, that's your aim there. So you can see that these ones here, okay, they are all going to hit near this yellow spot. So we're going to say these ones here are actually accurate. Okay, because they are close to the what? To the target. And then these ones here, they are far away from the target, which is this yellow spot. So we are going to say these ones are not accurate. Okay, because they are far from this target, which is the yellow spot. All right, so we've defined accuracy. Let's now define precision. Okay, so precision by definition, this is simply how close your repeated measurements are to each other, okay, even if they are not close to the actual value, okay? So how close the repeated measurements are to each other, even though they are not close to the what? To the actual value. So let's say my actual value is 25 grams. And then after doing the experiment maybe 3 times, okay, I find 39.1 gram, okay, and then I find again 38.9 grams, okay, and then I find 39 grams. So you see that these measured values of these measured results, okay, are actually very far from the true value because we are taking 25 to be our true value. These ones are very far from the true value, okay? But when you look at these measurements here, we can see that they are close to each other, okay? So we're going to say in this case that these measurements are not accurate, okay? Because even if you find the mean or the average of this, is going to still be 30 something, okay? So that 30 something is actually bigger than the 25 grams. So they're not accurate. But when I look at how close they are to each other, these measured values here, you can see they are very close because it says 39.1, 38.9, 39. If I round these, if I round all of these, okay, to the nearest ones, okay, you see that I'm just going to get a 39, 39, 39. So they're actually very close together. So these measurements are actually what? Precise. Okay, the measurements are precise, but they are not accurate because their average will not be close to the what? To the true value. Okay, so that's what precision is. It's just how close the repeated measurements are to each other, even though they are not close to the what? To the actual value. Okay, so if you say you have high precision, okay, then it means that your results are very consistent, meaning your repeated values, okay, are very close together like that. And then when you say we have low precision, it means the results are scattered or they are very far from each other. So let me give an example of the results that are not precise. So I'm going to say, maybe I have 25 grams, okay, and then I have 38 grams, and then I have 40 grams. So these are my three measurements. You can see that these measurements, okay, they're not close together. So we are going to say that those measurements are not what? Accurate. Okay, they're not accurate because they're not close together. This is 25, this is 38, this is 40. They're not close together, so they are not accurate. Okay, and then to find out if they are, these ones are not precise. Okay, not accurate. They're not precise because they are not close what? Together. And then to know if they are accurate or not, we need to find the average of this, divide by 3. So 25 plus 38 plus 40 divided by 3 gives me a 34.33, like that, grams. And we see that this average is not close to the true value. So we are going to say these measurements here, 1, they are not precise because they are not close together. 2, okay, they are not accurate because their average is very far from the what? From the true value. Okay, so that's what precision is. Okay, so let's look at the representation in terms of the diagram. So we have this diagram back. So this simply shows precision here. So these ones here, you can see that they are accurate, okay, because they are hitting close to the target spot, okay, which is this yellow spot. All of them are actually very near to the spot. But are they near to each other? Okay, they are not that near to each other. So we are going to say not accurate. Okay, they are precise, but they are not accurate because they are not close to each other. And then when you come here, they are very far from the spot. So these ones are not accurate. Okay, they are not accurate, but we are going to say they are precise. So here I was supposed to write not precise. So here, not precise. And then here I'm going to say they are precise. Okay, so why are they precise? You can see the spot that they are hitting there, it's almost the same. Okay, they are hitting at the same target. Okay, so this one is not accurate because it's far from the target, which is this yellow spot, but they are precise because they are hitting at the same, almost the same position. And then these ones are very close to the spot, so they're accurate, but they are not precise because they are not closer to each other. Okay, so we can compare them using a table. So in this table, I've written feature there, and then here I've put accuracy and there precision. Okay, so accuracy compares the values to what? Okay, so accuracy compares the values to the true or the actual value. Okay, and then precision compares to what? It compares the values that you have to the other repeated what? Measurements. Okay, so what is the meaning? Okay, or what do you want to achieve, or what do you want to know when you are investigating accuracy? Okay, when you're investigating accuracy, you would want to check the correctness of the measurements that you had. No wonder we are comparing them to how close they are to the what? To the true value. And then here on the precision, you are checking the consistent. How am I how consistent are my measurements? Okay, so if they are close together, we say they are consistent. It means they are precise. If they are not, okay, they will not be consistent and they won't be precise. Okay, so is it possible, okay, for the accuracy to be high? Yes, it's very possible for the accuracy to be high, and it's also very possible for the precision to be what? To be high. And then the possible combinations that you can have, okay, you can have high accuracy and high precision, okay? So meaning they are close together and they are hitting the target. Another combination that you can have high accuracy but low precision, okay? Like we saw in the previous diagram. Then another combination is that you can have low accuracy plus high precision. And then the fourth one is that both of them can be low. Okay, so I've represented these on this cute diagram. Okay, so you can see here, the target is that yellow spot inside there. So you can see that here, okay, we're hitting on the target and they are very close to each other. Okay, so we are going to say these ones are both accurate and precise. So the accuracy and the precision are both high. When you look at this second diagram here, you see that we are hitting, okay, somewhere which is far from the spot, which is yellow. Okay, so since we are hitting somewhere which is very far from the spot, okay, or the target, we are going to say it's not accurate. But since these are still close together like that, we are going to say they are what? They're precise. Okay, and then the other combination is this one. You can see that they are almost hitting the yellow spot. So we're going to say they are precise, but are they close together? No, they are not close together. So we're going to say they are not precise. Okay, and then these ones here, they are scattered and they are very far from the target, which is the yellow spot here. So they are both not accurate and they are not what? Precise. Okay, so that's the accuracy and precision by definition, and we've compared them. So now we need to look at an example examination question. So if you have any questions as we'll be solving this question, you are free to ask. Okay, so let us look at this question here. So the question says, four students, A, B, C, and D, measured an object 4 times each and recorded the results as shown below. So these are the results here for the 4 students. Okay, so question A, they're saying comment, okay, on how, comment on how low or high, okay, on each student in terms of the precision and the accuracy. Okay, and then B, they're saying comment on the type of error that affected the measurements for each student. Okay, so we're going to start with student A. Okay, let's look at student A. So are those measurements accurate? Okay, and are those measurements precise? Okay, so here, the true value, I didn't type it here, but the true value is, I was given the true value to be 25. Okay, so the true value, let me write it somewhere. I forgot to type it. The true value is 25 grams. So we are comparing whatever we have to this true value here. So for student A, if we want to know, okay, if these measurements are accurate, then we have to find the average of whatever I've been given there, right? Okay, so I'm going to say the average, or in short, the mean is equals to, or let me use the word average. So the average, we are going to add, so 3, 4.6 plus 3, 4.5 plus 34.7 plus 34.6. And then we're going to divide all this by 4. So this will just give me what? Okay, so let me punch that on the calculator. So I have 34.6 plus 34.5 plus 34.7 plus 34.6. So when I add that, okay, I get 138.4. Then I divide this by 4. So this will give me what? Okay, it gives me 34.6. Okay, so this is the average of the measured values for student A. So we compare it now to the true value. So this one here, okay, is the average. And then we compare it to this true value here. So are they close, those ones? Okay, no. Okay, so we're going to say for student A, I'll just write SA here. For student A, okay, the accuracy is very low. Okay, we are going to say not accurate, which simply means the accuracy is what? Low. So low accuracy. Okay, or simply meaning not accurate. Okay, what about the precision? So the precision, we look at the individual measurements. Okay, are they close to each other? Okay, so we have 34.6, 34.5, 34.7, 34.6. We see that they are all in 34s point something. So they're actually what? Precise. Okay, so we're going to say high precision. Okay, high precision like that. Okay, so that is for student A. And then let's look at student B. So student B, to check the accuracy, again, we need to find the what? The average of the measurements that are there. So the measurements there is 4.36 plus 4.35 plus 4.37 plus 4.36. So if I do this and then I divide by 4, okay, I punch this onto the calculator. So I'm finding my mean to be 4.36 grams. Okay, so now I'm comparing my mean, this guy, to my what? To my true value, which is 25 grams. Again, we see that this average is way lower than the what? Than the true value. Okay, so I'm going to say for student B, there's again low precision, low accuracy. Okay, the measurements are not what? Accurate, because The average there is very low. Okay, it's 4.36, but the true value is 25 grams. Okay, so what about the precision? The precision, we just look at the individual elements that we have there. Okay, so there's 4.36, 4.35, 4.37, 4.36. Again, these ones are very close to each other. Okay, so we're going to say high precision. Okay, if I rounded all these values here, I'll get 3. Okay, if I rounded 12 to the nearest one, I'll get 3. So they are all close. So the precision there is very high. Okay, what about student C? So student C, let's find the average to check the accuracy. So student C, I have 24.9, okay, plus 25.1 plus 25.0 plus 24.9. So I divide all this by 4. So let me punch this, okay? So also do it on your own calculator. So my average, I'm finding 24.975 grams. Okay, so this is what I'm finding there. So I'll ask myself now, is this average here close to the true value, which is 25? Yes. Okay, the answer is yes. 24.975 is very close to 25. So for student C, I'm going to say high accuracy. Okay, or simply that the measurements are what? Accurate. Okay, so the accuracy there is high. So high accuracy because the average there is closer to the true value. Okay, what about the precision? The precision will look at the individual measurements. So this is 24.9, 25.1, 25.0, 24.9. So these measurements, again, they are close to each other. Okay, if I rounded off each of these, I'll get a 25. So they are very close. So I'm going to say high precision for student C. Okay, what about for student D? Okay, um, let's find the average to compare the to the true value so that we know if they're accurate or not. So here I have 64.6 plus 34.5 plus 14.7 plus 10.8. So I divide by 4. What would be the average? Okay, so once I divide by 4, I'm getting my mean to be 31.15 grams. So I compare my mean now to my true value. So my mean is 31.15. My true value is 25 grams. So we see that this mean here is way above the 25 by 6 grams because this is 25, this is 36. So if I add 6 to the 25, I'm going to get 31. So this average here for these measurements on student D, they are way above the true value. Okay, so student D, we're going to say it has low accuracy. Okay, what about the precision? The precision, we check the individual measurements. How close are they to each other? Okay, so here we can see that we have 64 point something, 34, 14, and 10. All these measurements here are not close to each other. Okay, they keep on jumping. They're just random. So we're going to say we have a very low what? Precision. Okay, so we are done with part A there, where we are commenting if the accuracy is high, simply meaning if the measurements are accurate, okay? And if the precision is high, simply meaning that the measurements are what? Precise, or if they are low. Okay, so we have found for each what? For each student there. So that was part A. This one here was part A, 1, okay, and what? And 2. So now, let's look at B. So B is saying comment on the type of error that affected the measurements. Okay, so before we comment, I have to explain. So there are 2 types of errors that affect accuracy and precision. Okay, one of them is what we call as the random error. Okay, it's what we call as the random error. And then the other one is what we call as systematic. Okay, so we have systematic errors and then we have random errors. So random errors are the errors that occur, okay, when in your measurements you have values that are both below the true value and above the true value. So if, for example, if my true value was maybe 10 grams, okay, and then I do 4 measurements, and then my results show some values like 5 grams, okay, maybe 4 grams, and then some other values, they show 12 grams and maybe 16 grams. So we Okay, so I was explaining on the two types of errors that we have. I said we have the random errors and the systematic errors. Okay, so on the random errors, let's say the true value is 10 grams like that. Okay, and then I make 4 measurements. So of those 4 measurements, let's say I get 5 grams, 4 grams, 12 grams, and 16 grams. So you see that of these 4 measurements, 2 of them are below the true value, okay? And 2 of them are above the true value. So it means these measurements here experience random error because some of the measurements are below the true value, some of them are above, okay? And then when you come now to the systematic errors, these are errors that are going to be happening in one direction. So if my true value is 10 grams, okay, and then I have a set of 4 measurements, let's say 13 grams, 12 grams, okay, and I get 12.5 grams, 13 grams, okay, or maybe and 14 grams. So you see that all these measurements here are above the true value, okay? So if all your measurements are above the true value, then they are experiencing a what? They are experiencing systematic errors, okay? Again, it's true for the other round. So let's say my true value. Okay, I'll just increase the true value here. So let's say my true value was maybe 15 grams. And then my measurements give these results as well. So you see that all of them here are actually less than 15. So that is systematic what? Error. Okay, so the systematic error happens in one direction. It's either all your measurements are going to be above the true value or all the measurements are going to be below the true value. And then the random errors, they happen in both directions. So you expect that among your measurements, you're going to find some values that are going to be lower than the true value, okay? And you're also going to find some measurements that are above the what? The true value. All right, so now having explained this, we can actually state what type of error affected each of these measurements. Okay, so we start with student A. So the true value is 25 grams, okay? And I see here I have 34.6, 34.5, 34.7, 34.6. So all these here, they are above the true value. Okay, so for student A, we're going to say the error that they experienced there was just systematic. Okay, it's in one direction. All the measurements that they did were actually greater than the true value. Okay, so such errors arise because of uh, a default in the measuring instrument that you are using, okay? Or sometimes it happens because of the zero error. So let's say your balance, okay, if this is your balance and then it has a reading somewhere there, if you put nothing on the balance, okay, it still reads maybe 1 gram. So whatever you're going to put on this balance, okay, it's going to be its weight plus the 1 gram. So it will be always above the what? The true value. Okay, so that's where the systematic errors arise from. So for student A, these measurements here, they are experiencing a systematic what? Error. Okay, what about student B? So student B is the same because I have 4.36, 4.35, 4.37, 4.36. Again, all these measurements, 4 point something, they're actually less than this. Okay, so the error is in one direction. Okay, which has been lower than the what? The true value. So even these ones here are experiencing systematic what? Error. Okay, and then we look at student C. So what error affects student C? For student C, you can see I have 24.9, 25.1, 25, 24.9. So the true value is 25. So this 24.9 is actually below the 25. And then the 25.1 is above the 25. So there, the error that is there is actually a random error because the measurements, okay, or the errors are going in both directions. We have those values that are greater than the true value, and then those values that are less than the what? Than the true value. So the error there is the random error for student C. Then for student D, okay, let's take a look at the measurements. We have 64.6, 34.5, 14.7, 10.8. Okay, so you see that some of them, this 14.7 and 10.8, they're actually less than the 25. And then 64.6, 34.5, they're actually greater than the 25. So the errors are happening in both directions. Okay, so we're going to say the errors there are actually what? Random error. Okay, so any questions there, guys, on what we've done? Any questions there? Okay, so if there are no questions, we end here. Okay, but I've put some questions for you to, guys to try out. Someone has a question?
Yes.
Yes, you can ask.
My question is on the accuracy.
Yes,
Like we are finding the average.
yes, we are finding the
Why can't we
average.
just go there?
No, we can't go direct
Why can't we
because,
just go there?
yeah, so we can't go direct, okay, because we have a lot of measurements. I mentioned it at the beginning of the class. I don't know if you are there. So for the accuracy, you can only go direct if you've been given one measurement. Okay, so you've been given the true value and one measurement. That's when you can compare them directly. Okay, but if you have if you have more than one measurement, let's say two measurements, three measurements, four measurements, you always have to take the average of those measurements and then you compare the average to the true value. That's how it works.
Okay, sir.
All right, so any questions, guys? Okay, so these are some of the simple concepts that you're going to learn in chemistry. Okay, so I've taught you how to determine if they are accurate, how to determine if they are precise, and also the errors that affect accuracy and what? Precision. Okay, so I'll end here, but I've put some questions that you can try out. Okay, so you've seen this question here. It's just the same like we did. I've just changed it to my numbers there. So you have to determine if they're accurate or they're precise. Okay, you can also state what type of error affected those measurements. Okay, so you can screenshot this, and I've also put this one. This is an assignment here. So I'll share this assignment in the groups so that you can actually try it out. Okay, so these are the questions that you are going to find. All right, so thank you so much for attending. Okay, for those who are ambitious enough, we have a website, okay, where we have lessons on all the NS topics that you're going to learn. Okay, so you just go on Google Chrome and then you type discretelearning.com. Okay, so it's going to take you to our to our website, I mean. Okay, so this is our website here. You can see we have the courses for NS, there's mathematics, chemistry, physics, and biology. So you subscribe for whatever uh, for whatever course that you want. Okay, so if, for example, you subscribe maybe for chemistry, since we are doing chemistry here, okay, you go in this folder written as general chemistry. Okay, and then here you'll find lessons and tutorials, summarized notes, tutorial sheets and assignments, past paper, quiz and exam papers, and then there we have some lab report samples. So you can actually use this. So whatever tutorial sheet that you're going to have, we'll be solving them and we're going to be uploading them there. Okay, and even right now, there are tutorial sheets they are solved. So if you like to learn, you can actually subscribe from the website and then access them. And then here,